I just ran a test, and the results, quite honestly, were a little bit surprising to me. So let me show you the test after I explain my purpose for it. What I wanted to do was find out what would burn the longest and what would put out the most heat. So I set up a test with 8 candles, 4 that were grouped close together and 4 that were spread apart, to see which one would burn the longest and which one would burn the quickest, as well as which one put out the most heat along the way. I proved a couple of things, some of which I wasn't really expecting to. But let me let you watch it, and then I'll finish up afterwards, give you some more info. So let's go. So we're going to start off excuse me, by lighting the candles. My long lighter somehow didn't enjoy being lit working facing down, so I had to use another lighter. But number 8 candle, I numbered all these so that I could talk about them easily. The number 8 candle I had in the freezer for about an hour, and it was about 10 degrees cooler than room temperature. Not really all that much worth worrying about. So I lit them up, and about a half an hour later, the wax is getting well melted, and it just is going along. I ran the infrared thermometer on it just to see how it went. I came back every once in a while, about every 10 minutes for the first hour or two, to see if there was any real difference in them, and I'll post all of those observations as well as the full time lapse to let you see how that went. Another half hour in, I gave it about 30 seconds per half hour, and really about as exciting as watching paint dry or grass grow. Nothing really amazing. All of the candles are well melted, everything's going good. The big thing that I wanted to prove or find out was whether or not the 4 candles close together would burn faster simply because there was more wax available to flow up the wicks, and therefore put out a little less heat over less time, so forth, versus the candles spread out having the ability to burn longer. It doesn't look all that different. All of the temperatures were the same in all the waxes. Everything was looking identical across both of them. And that was really surprising in what happened next. It's almost 3 hours in, and this is where I started to get shocked. I was not expecting this to happen. Again, I went into this saying there's really not going to be a difference, but number 7 just went out at about 3 hours in. And I was not expecting that. My question with this was, which layout is going to produce the most heat for the most time? And as you can see, totally unexpected by me, I ended up with the 4 candles burning for the longest. the clumped up ones burning for the longest. It just blew my mind. Even that little teeny tiny flame goes out really close to the same time as number 2, which is the first one of the 4, if I remember correctly, to go out. It's either 1 or 2. Give it a minute and it'll get there. But this tells me it's number 1. There it goes. Number 1 has a teeny tiny little flame. Number 5 goes out. There goes number 1 completely. The best way to get the most heat for the most time is to have the 4 candles or more very close together. There goes 4, so that they can contribute to their length of burn. And we have number 2 go out at about 1:36. Then number 1 goes out just a couple minutes later. I hope that you're as surprised as I was about this result. I certainly wasn't expecting it. Now, the one thing that I proved that I wasn't expecting to, nor did I really plan to, was that if you keep a candle cool by putting it on ice or whatever you do to prevent it from staying up to temperature, it might actually burn a shorter amount of time. Now it's obvious that starting it frozen allows it to run longer, just because it takes longer to get all of the wax melted and flowing well. I will be interested to see if, after I do a couple of tests, I can try that with 4 candles and see if it makes a real difference in output temperature and total run time. That's not something I can do at this moment, and I want to prove a couple of things and make sure that everything's in good shape before I do that. But starting now, I want to use this that I built to set my thermometers on and run the sensors out to the side so that I can put them in strategic locations on the pots. I'm not sure exactly how that's going to look and exactly how it's going to end up, so hey, throw me in a suggestion on what would be the best place to put the sensor. But then I'm going to start doing tests, starting with a baseline and going up from there. I don't know where it's going to go. I don't know what I'm going to prove. But the biggest thing that I want to do is see, number 1, what's the quickest way to get temperature? Because if you really are in an emergency situation, your first and foremost interest is getting the temperature above 40, 45, because you can be wearing jackets or a bunch of clothes and be okay at that temperature, but you want to get temperature fast. The other thing is to find out how much heat total I can get out of this system. Finally, the amount of time that I'm going to be able to get out of this. The more mass I have, the more it's going to work. We'll see what happens. But there is no catalyst in this, so anything more than a extended burn time or just more heat being collected and dispersed, we'll just have to see. My personal assumptions and hypotheses are going to be either proven right or wrong, and we'll see what it means, where it goes, and how it goes, because I'm going to do this several times. One other thing that I want to make sure is fully understood here is that I am not trying to prove or disprove this setup. It is well known and well understood that one candle can put out about 100 watts of power continuously. And so when you put something over the candle to collect and radiate the heat, you're still not going to get more than 100 watts per candle. And so 4 candles are going to actually put out less heat than a space heater on low. This puts out about 500 watts continuous, and it has a fan pushing it through the room. So you're never going to get a large space heated just because of, the laws of thermodynamics with 4 candles. Now, 8 or 12 or whatever it may be, you might get there, but then you have to worry about other factors like carbon monoxide and little things like that. But 4 candles by themselves are never going to put out enough heat to warm a large space. 10 or 12 feet square, maybe. But, not 15 by 15 or larger, something over 12 foot square. That's not what I'm trying to prove or disprove. What I'm trying to find is simply how much heat, how quickly, and how long this works. I want to know if the candles put out less heat as they get lower. I want to know if it holds heat. I want to know how quickly it comes up to heat. Those are the things that I'm trying to prove, not whether or not I can heat a space. Anytime you put a heat source in a space, if it has enough power, enough BTU, wattage, whatever going out, it's going to heat up the space. It is a very well-known fact that these have a specific amount of heat that they can put out, which is about 400 watts continuous. So I'm not trying to prove or disprove that. This is a good system for what it is, and I just want to see what I can do with it. So that's why I'm testing. Thanks for watching. Stay tuned and I will start doing more tests.